Unit 10, Lesson 3, trig ratios using a coordinate point.
The goal for this section is going to be using a coordinate point that's on the terminal side of an angle to calculate trig ratios. So this, again, we're looking at graphing angles on the coordinate plane, and now we're going to take what we know about the 6 trig ratios and use that on the coordinate plane. So here are the steps, and they tend to make a little more sense once we look at an example. But basically, we're going to draw an angle, create a reference angle, so we have a right triangle, and then use Pythagorean theorem like we did in the first section. The only thing that's different is we're going to have different signs with our answer. So we want to be real careful because we're thinking of the coordinate plane and what values are positive, what values are negative. But it's still the same concept. This right here is going to be helpful. So if we have a coordinate point in the form of x, y, we consider r to be like the radius if I'm drawing a circle, or the hypotenuse essentially. And we're going to have these 6 different ratios. So we'll reference these again, but just so you kind of know how sine, cosine, and tangent is going to work on the coordinate plane. All right, so the first one is saying find all 6 trig ratios, and they give you a point that the terminal side is going through. So if I look at if I sketch an angle, I know I have my initial side, which is not going to change, which is on that x-axis. If I think of plotting the point negative 5, 12, negative 5, and then 12, I'm going to actually write that point here, so negative 5, 12. And it doesn't have to be perfect, again, it's just a sketch, but basically we know that that's going to live in quadrant 2, right? That's where this point's living. So if we think about where that falls, this is between 0, 90, 180, 270. You can see it's going to fall, it's an angle that's really going to be between 90 and 180. Okay, the question's not asking us to find the angle though. We're really just going to go ahead and calculate our different trig ratios. So what we're going to do is I'm going to drop this straight down. And we're going to revolve around this angle right here. This is our reference angle. So they give us this theta. I'm going to use the reference angle to answer this problem. Okay, so we're using this like blue triangle right here. Okay, so let's go ahead and label this out. So if I'm looking at negative 5, 12, I'm going to label this down here negative 5, and I'm going to label this as 12, right? Because I went to the left 5 and I went up 12 for this point. So this is my x, this is my y. Okay, so really when we're thinking about negatives, we're thinking about direction here. And I'm going to treat that as a negative 5 and a 12. If I want to find the hypotenuse, sometimes we call the hypotenuse r, because if I was to revolve it around it would be like a radius of a circle. And just like we saw in the first section, we're going to use Pythagorean theorem now to find that side of this right triangle. So I'm going to do 12 squared plus negative 5 squared equals r squared. Oh, sorry, that's 144. I'm jumping the gun here a little bit. And then we'll get that to be 13. Okay, so now from here, again, I'm revolving around this reference angle. I'm going to go ahead and find sine, cosine, and tangent, right? Because sine, cosine, and tangent of the reference angle, if we take into account sines, is going to help us do the problem. So if I label everything, this would be my opposite. This would be my adjacent. This would be my hypotenuse. And then I can see my sine would be 12 over 13. And notice sine is positive because, again, it's your 12 is positive, and the radius we always treat as positive. You can see cosecant then would be 13 over 12. Cosine, your adjacent, we're treating like a -5, right? Because that's the point. So -5 over 13. Write it over here. The reciprocal would be -13 over 5. And notice that's a negative cosine, right? So, which makes sense. The x value, if cosine's x over r, and your x is negative, cosine would be negative. And then finally, the last one is tangent. Tangent would be opposite over adjacent. So that would be 12 over -5, or -12/5. The whole thing is going to be negative. Or the reciprocal is -5/12. And again, the whole fraction is negative, which makes sense because if the adjacent is negative, any ratio that uses the adjacent is going to be negative because that's where the point fell. And this would be your final answer. The next example is very similar. So we're looking at we're finding the trig ratios for an angle in standard position where the terminal side goes through -1, -4. So I'm going to go ahead and do the same thing. I'm going to sketch an angle. I know it's has the initial side. And if I look at -1, -4, you can see that's going to fall into quadrant 3. Okay, so I'm going to, and I kind of exaggerated the angle a bit just so we can make a nice right triangle, but it's the same concept. So I'm now going to make a right triangle, and I always form it with the x-axis. Even though it's tempting to want to do the y, you're not going to do the y, you're going to do the x-axis. So really what we have here is I'm finding sine, cosine, and tangent of this larger angle, which is the same as the reference angle. Right, this little angle right here. So I went over -1, I went down -4. So I'm going to treat that because I'm using the direction of -1, -4. And then same thing, I'm going to solve for r, which is the hypotenuse. So when we solve that, we're going to do -4 squared plus -1 squared. When we square a negative, we always get a positive. And we're going to get root 17. And then our value or our hypotenuse is always going to be treated as positive. And now we're going to do the same thing. So if I label everything in relation to this angle, this is my opposite, this was my adjacent, this is my hypotenuse, or you could think of it, again, your x value, x over r's, cosine, and so forth. So you can think of it however you like. And so sine would be -4 over root 17. And that's the whole thing's negative, right? Then the cosecant is the reciprocal, and I'll rationalize them all at the end. Cosine is -1 over root 17. And then the reciprocal would be -root 17 over 1, or -root 17. And then tangent would be opposite over adjacent, so 4 over 1, or 1 over 4 for cotangent. We do have to rationalize, so we can rationalize our sine and our cosine. So -4 root 17 over 17. And then this one I'll rationalize down here. And you get -root 17 over 17. And those would be your final answers.
If you have any questions, you can ask in class, sign up for T-Will time, or go to the center.